Okay, hello. I'm going to review all the Chapter 13 materials on quadratic functions. So this is going to look very similar to the last review that I did, different problems, but the same types of directions. So in these first three, actually the first five that I'm going to do, you're going to factor each of the trinomials. We're not going to set them equal to 0 or anything, but we will end up using a couple of the rules for difference of perfect squares, and we will use factoring perfect square trinomials. So first one, notice that your lead coefficient is 1. So this is the type of problem where you're just going to break apart the two parentheses right away, and you'll put the x's in each of them. Now I'm looking at my factors of negative 27 that add up to negative 6. So this tells you that one of them has to be positive and one of them has to be negative. This sign tells you that the greater of your two factors is positive. So your factors of 27, the ones that I'm thinking of, are 9 and 3. And if I use 9 and 3, positive 9 times negative 3 is negative 27, and positive 9 plus negative 3 is where the positive 6 is coming from. So that's that one. With this one, it's a binomial, so what I would say is look for your perfect squares, which the square root of 16a squared is 4a. The square root of 9 is 3. So according to the rule, you're going to also have two parentheses for this, and one of them will contain 4a plus 3, and the other set will have 4a minus 3. Alrighty. Okay, number 3. So the lead coefficient in question 3 here, the lead coefficient is positive 2, so the lead coefficient is greater than 1. So what that means we're going to do first is look if there's any kind of factor that we can take out of all three of these, and there isn't, so it's not like I can take a 2 out. So what I'm going to do is break apart the parentheses. We're going to put 2x in one of them and x in the other, because 2x times x would give us the 2x squared. Now, this sign right here is going to tell us either positive, positive, or negative, negative. This tells us that both of our factors actually do have to become negatives. Now, as far as the factors of 15 go, there's either 1 and 15, or there's 3 and 5. Now the thing to remember is whatever factor you put in this position right here is the one that gets multiplied by the 2. So like if I put a 15 here, you'd be multiplying 15 by 2 to get 30, and then you would put a 1 here, it's not going to give you 13. So we need to look at the factor that is going to go right here that we're going to multiply by 2. So I'm going to put 5 there, and I'll put a 3 here. And again, the reason for that is if you do 2x times x, that's the 2x squared. Now 2x times negative 5 is negative 10x, and if you have a negative 3 times x, that's going to give you negative 3x. So again, the negative 10x and the negative 3x are where the negative 13x is coming from. The negative 3 times negative 5 is positive 15. So you can use that distributive property to check your answer, but that is it. Next two. Okay, so for this one, also look and see if you can take anything out at first. Doesn't look like it. So before you can even break this up and factor it, I would say look if there's perfect squares, and these are perfect squares. The square root of 4x squared is 2x. The square root of 9 is 3. So you need to check to see if we can use the perfect square trinomial rules, which means if you multiply these two things together and then multiply it by 2, you should get the middle term. So 2x times 3 is 6x, and if you multiply that by 2, you get to the 12x. So what that tells us is we can use our rules.
Route 64 has arrived. If you're waiting for Route 64, please come get on your bus. It's not going to be here long.
These people need to stop making announcements. Okay, so it's going to be 2x minus 3 squared. The reason for the minus is this sign right here. Okay, so if this were to be a plus, you would just bring a plus down. Okay, and that is it. This is the factored form of that perfect square trinomial. With this one, what you're going to want to do, first of all, you do not have perfect squares on the ends. And you can see that you have all even numbers. You're going to take a 2 out of everything. So you are factoring a 2 out, which means you're dividing each one of these by 2. So 2p squared divided by 2 is just p squared. Negative 18p divided by negative 2 is negative 9p. And then positive 2 divided by positive 2 is positive 1. And that is your final answer. You cannot go any further with this because there are no factors of 1 that are going to add up to negative 9. So there's nothing that you can do beyond this for factoring. So that is it. For these ones, we're going to be solving these equations, which is basically where they're just set equal to 0. So the first one, notice I only have two terms for this. What we're going to end up doing is factoring something out of both of these. So the greatest common factor as far as a whole number is 2, and for a variable you can remove an x from both, or you can factor out an x from both of them. And you're going to do this very similar to how we did that last problem, where you're going to divide 8x squared divided by 2x is 4x, and negative 10x divided by 2x is negative 5. So then all you have to do from here is take the 2x and set it equal to 0, and take the 4x minus 5 and also set that equal to 0. So what we're going to do is divide both sides by 2 here, and 0 divided by 2 is 0. And right over here we're going to add 5 first, so 4x equals positive 5, and you are going to divide both sides by 4. So x equals 5 over 4. So we have our two areas where this function crosses the x-axis. One of them's at 0, the other one's at 5 over 4. Okay, so this one, again, just to kind of recap, this was factoring by greatest common factor, and then we set it equal to 0. With this one, this kind of looks like the second half of one of those completing the square problems, where you notice something on the left is written in like a factored form type thing where you have the squared. So what we're going to do is actually square root both sides first. So you end up with the square root and the square cancel each other out, and you're left with x minus 3 equals the square root of 16 is plus minus 4. And what you're going to do then is just break this apart into two problems really. You have x minus 3 equals positive 4, and x minus 3 equals negative 4 because of the plus minus. So the first one is going to come out to positive 7, and the next one is going to come out when you add 3 to negative 1. So this function crosses the x-axis at positive 7 and negative 1. Alright, moving on. Okay, next one we're going to do that completing the square. So we're going to complete the square, and this is provide an exact answer in simplest form, and then I want the decimals rounded to the nearest hundredth. Okay, so the first step in completing the square was to move that constant term to the other side. So I'm really going to have x squared minus 6x plus something, and I'm going to bring the 9 over, and I'm also going to put the plus something over here. So now what we're going to do is turn this left side in. We're going to force it to be a perfect square trinomial. So what I'm going to do is take this b term, which is negative 6, and I'm going to put it over 2a. Now your a value is 1, and 2 times 1 is 2. And you are squaring that. So it's always the b over 2a, and then you are squaring this. So this inside part comes out to negative 3, and negative 3 squared is 9. Okay, so you're going to be adding 9 to both sides basically. The left hand side, we're going to factor this trinomial right here, which is a perfect square trinomial, and it's going to factor into x using this minus 3 squared. So again, the minus 3 comes from this value right here, and we're going to set this equal to 9 plus 9, which is 18. So now what I'm going to do is square root both sides. So now this looks just like that last problem that we did. On the left side, you're left with x minus 3, and on the right side, I have plus minus the square root of 18. So I'm going to simplify this, so I still leave the x minus 3 there, plus minus. Now I'm going to break apart the square root of 18 into the square root of 9 times the square root of 2. So I'm looking for really the largest perfect square that goes into 18. 9 is a perfect square. The square root of 9 is 3. And then you would just bring the radical 2 down. So we are almost done with that part. The last step, I'm going to go way up top over here. This minus 3, we would need to add 3 to get x by itself. So your final answer is x equals plus minus 3 times the square root of 2. And then by adding that 3, you would have a plus 3 over here. So this is your final answer for the exact form. So that's your exact. Now I'm going to do the decimal version, which is where in the calculator you're going to take 3 times the square root of 2 plus 3. And I'm doing this in my calculator. 3 times the square root of 2 plus 3. Rounded to 2 decimals gives me 7.24. And then the other one is we're going to use negative 3 times the square root of 2. And I'm also going to add 3 to that. And that comes out to negative 1.24. So these are your two answers then. And these are, again, the decimal form of that answer. Okay, so that was completing the square, and we were giving our answer in the exact form, and we have the decimal form. Next four. Okay, these are the ones where you're going to perform the operations like adding and subtracting and multiplying the polynomials. The first couple I think are a little bit easier. Adding them, all you're going to do is drop the parentheses between these and combine like terms. So I'm going to drop the parentheses first. Okay, drop parentheses. Now we're going to add our like terms. So 2x squared plus another 2x squared is 4 of those x squareds. Remember, make sure you do not do anything with the powers when you're adding 2 of those. You are only combining the coefficients from them. You have negative 3x minus 7x, which is negative 10x. So that takes care of these 4 terms, and then we just have the plus 1. Throw that on the end. So now I hit all of my 5 terms, and we are done. That is the simplified form of that polynomial, and it is in standard form because it's arranged from highest power to lowest power. For this one, we have a minus, which I want you to think about it like it's a minus 1. So you're subtracting the polynomials, which means you have to distribute negative 1 through. So your first one, you're just going to drop the parentheses, and it's 3x minus 4. Now you have a negative 1 times negative 5x, which is positive 5x. And you have a negative 1 times a negative 1, which is positive 1. So combine like terms again. 3x plus 5x is 8x, so that takes care of those two. And then you have a 4 plus a 1, which is 5. So final answer is 8x plus 5. With the multiplying, these ones you're going to use a distributive property. So what I'm going to do first is I'm going to take this 3x squared, and I'm going to multiply it by both of these terms. So first of all, 3x squared times 3x is 9x to the third power, because x squared times x is where the x to the third is coming from. I'm going to take 3x squared times positive 4, so that's positive 12x squared. Now, I'm done with this. Go on to the next one. So negative 2x times 3x is negative 6x squared. I have a negative 2x times a positive 4, which is negative 8x. So now I'm all the way done with this one. And last, you're going to distribute the negative 1. Negative 1 times 3x is negative 3x. And negative 1 times 4 is negative 4. So think about it. You have a trinomial times a binomial, which means I should be having 6 terms. So if you count them, 1, 2, 3, 4, 5, 6. So that makes sure that I got everything. Now you just simplify them. So 9x to the third. I have a 12x squared and a minus 6x squared, so that means I'm going to have a plus 6x squared. I have negative 8 minus 3, which is negative 11x, and then the minus 4. So that is your final answer for that one. And then lastly, this is a binomial times a binomial, so 2 terms times 2 terms means I'm going to end up with 4 terms at first before we simplify it. So 4x times negative 3x is negative 12x squared. I have a 4x times negative 7, which is negative 28x. Takes care of this. Now the inside one. 1 times negative 3x is negative 3x. And 1 times negative 7 is negative 7. So it takes care of that. And now you're going to write it in standard form, which again, you only have the negative 12x squared. The inside terms are going to simplify to negative 31x, because it's negative 28 minus the 3, and then you bring the minus 7 down. So that is that one. Again, this is standard form of a polynomial. Last one. Actually, second last one. This one says, how many times will the parabola cross the x-axis? So we're going to solve algebraically first, using that thing that we called the discriminant, and then we're going to graphically do it just to prove our calculations. And when we do a graph, I'm just going to use the graphing calculator and show you guys how to make a little rough sketch in that. So first thing is to do the discriminant. Discriminant was that part inside the quadratic formula where it had b squared minus 4ac. And we knew that, or we talked about this in class, that if this came out to a positive number, meaning something greater than 0, you would end up with 2 solutions, which mean it would cross the x-axis twice. If this inside part came out to 0, you would cross the x-axis 1 time, and if it came out less than 0, it would not cross the x-axis at all. And that would be for if the discriminant were negative. So I'm going to identify what A, B, and C are. So A is 3, B is 4, and C is 2. So now I'm going to do B squared. So that's going to be 4 squared minus 4 times your A value times your C value. So this is 16 minus 4 times 3 is 12, and 12 times 2 is 24. And 16 minus 24 is negative 8. Now, since this is less than 0, so the b squared minus 4ac is less than 0, that means we are going to have no real solutions. So it actually will not cross the x-axis at all. And to prove that, we're going to go to the graphing calculator. So I'll do it in my graphing calculator. I'm going to go to y equals. Oh boy, I need to turn this off. Okay. Go to y equals, and I'm going to put in 3x squared plus 4x plus 2. And what I'm going to do is go to window, and I'm going to adjust it so that it looks like my pretty picture here, which you're going to make your the minimum x value is 5, your positive x value is 5. I'm going to count by ones, and then I'll do the same thing for the y value. So this is giving us basically a 5 by 5 graph. The x and the y scale just mean we're counting by ones. So then I'm going to hit graph, and notice that the function comes down and does not cross the x-axis. So just make a little sketch of what this looks like on your graph, which was something like this. And again, it does not have to be perfect. The idea is that you see that it does not cross the x-axis, which means that it has no zeros technically, no real roots. Alright, last problem then. So a model rocket is launched with an initial velocity, which I'm going to change so that these numbers actually do work out. This is totally a typo. This should be 150 feet per second, which means if I change it there, I need to change it down here as well. This should be 150 t. Okay, so make that change real quick on your sheet if you guys are following along. So change that so it is 150 and not just 50. So a model rocket is launched with that initial velocity, and I'm giving you this function right here to model the rocket's height as a function of time. And we want to figure out basically how many seconds, so we'll be solving for t, after the launch will it take for the rocket to get to 150 feet above the ground. So we will round our answer to the nearest hundredth. So the first thing we're going to do, we're going to solve for when it equals 150 feet. So we're going to be substituting a value of 150 in for h of t. And like I said, we're technically solving for t, which we're going to end up using the quadratic formula for this. So in order to use the quadratic formula, you're going to need to bring this 150 to the other side first. So I get 0 equals negative 16t squared plus 150t minus 150. And from here, you're going to identify your A, B, and C values. So A is negative 16, B is 150, and C is negative 150. Okay, so now we're going to take those A, B, and C values and substitute them into the quadratic formula. So it's going to be x equals negative, or opposite B, so negative 150, plus minus the square root of b squared, so 150 squared, minus 4a, which is negative 16, times c, which is negative 150. And all of that
Mr. Klemp,
is going to be over 2a, so 2 times negative 16. And then we're going to simplify this. So I would definitely suggest pausing this video and trying it yourself and then going back and checking. I'm just going to keep working through it. So that's negative 150 plus minus the square root, and I'm going to throw that in my calculator as 150 squared minus 4 times negative 16 times negative 150. And inside this, I get 12,900. Oops. And all of this is over 2 times negative 16, which is negative 32. So then what I'm going to do is take that square root of 12,900. So I end up, and I'll do that to 2 decimal spots. So I'll take the square root of 12,900, which is 113.58. And all of that is over negative 32. So now you get to the part where we're going to break it up. into two equations. So one of these equations, you're going to do x equals negative 150 plus 113.58 over negative 32. And with the other one, we're going to do negative 150 minus 113.58 over negative 32. And again, think about it. The rocket is going to go up in the air. It's going to hit 150 feet. It's going to keep traveling up, and it's going to hit a maximum height, and then it's going to start coming down, and when it comes down, it's going to hit 150 feet again. So we're actually going to have two answers for this where it will hit 150 feet. So I could even ask the question and say, how long will it take before the rocket hits its maximum and then hits 150 feet, which means I would be looking for the second time value. But again, we are going to have two answers for this. So I'm going to put in my calculator negative 150 plus 113.58, hit enter after that, and then divide your answer by negative 32. We want to do the order of operations where we're putting this top part first because we're adding, and then we're going to divide. And I get an answer of 1.14 seconds. And then for this one, I'm going to do negative 150, and I'm going to minus the 113.58. Hit enter because that's going to allow your calculator to do this top part, and then divide it by negative 32, and you should get 8.24 seconds. So again, you have these two answers where the rocket is actually going to go up and, oops, what just happened? Anyway, the rocket is going to go up and hit, oops, there we go. Okay, the rocket is going to go up and it's going to hit the 150 feet at some point, and then it's going to hit its maximum, and then when it comes back down at 8.24 seconds, it'll hit the 150 feet again. So that's why there are two answers for this. And that is everything that you will see on the Chapter 13 assessment.